So we've covered sketching the graph of the derivative of a function, how we can use the key characteristics and key parts of the original graph to translate this over and see how they would relate in the graph of the derivative. What I'm going to do here is I'm going to give you a couple of graphs of functions. I want you to take these away, pause the video, and see if you can sketch the graphs of the derivatives of each of these functions. Here you go. So I want you to sketch the derivatives of the following three functions. So your first function here is going to be a quadratic. Second function here in the top right is a cubic function with these two key points. And your third one here is a quartic with three key points marked on. So pause the video and have a crack. So the first one we're going to look at is the graph of the quadratic function there. Now in the quadratic, I'm telling you that it's got a minimum turning point of 2, 3, and it looks something like this. Now remember, when we're looking to sketch the graph of the derivative, there's a couple of key bits of information we look at. First being that turning point there, because what that tells you, turning point, stationary point, that's where the graph is stationary, i.e. there's no rate of change, so the derivative at that point is 0. What that means is, that's where the roots of the derivative are. So the turning point is 2, 3. What that means is when I sketch the graph, it's going to cut the x-axis at 2. So it's going to cut there when I do the derivative. What I now need to look at is the behaviour of the function. Now this side here has a negative slope. So it's sloping down the way. This side here has a positive slope. Now remember, for a negative slope, that means the gradient of the curve is negative. We could translate that over to the derivative by saying at that point it has to have a negative derivative. So basically what that means is below 2 we're going to have a negative value. Now one thing to remember as well is this is a quadratic. Highest power is x squared. When we take the derivative we go down 1 in terms of power. So my derivative for this one is a linear function, i.e. a straight line. So I know that below 2 is going to be a straight line that goes off in the negative direction. Above 2, my gradient, my curve is positive, it's sloping up the way, so my derivative is going to be positive. So above that point, it slopes up that way. And that there is a sketch of my derivative for that one. It's a straight line, cuts at 2, negative below that, positive above it. Second curve was a cubic. So it's a cubic, it's got two turning points, one at 2, 6, one at 8, negative 2, and I want to sketch it. Now again, the key things to remember. 1, it's a cubic. So that means that my graph of my derivative is going to be a quadratic. 2, we use the stationary points to determine the roots. So I've got one stationary point at 2, 6 and one at 8, negative 2. What that means is when I draw my derivative, it's going to cut the axis at 2 and it's going to cut at 8. Now, when I'm doing this, I can look at the graph here and I can determine the values of the derivative based on it. So this one here has got a positive gradient, so it's going up, though it's a positive slope. Bit in the middle between the two turning points is negative, and the bit above it has a positive slope. So what this tells me, gradient's positive here, so my derivative's positive. Gradient's negative here, my derivative's negative, and gradient's positive here, so my derivative's positive. What that means is up to 2, my derivative's above the x-axis. Between 2 and 8, it's going to be below, but remember, because it's a quadratic, it goes down and curves back on itself. And then above 8, it's going to be a positive slope. So it's going to look something like that. It's going to be a quadratic that cuts at 2 and 8, negative between 2 and 8, positive beyond 2 and 8 either side. Last graph we had was this quartic here. So it's an x to the power of 4, that's our highest power there, which means our derivative is going to be a cubic. So we have to bear that in mind first. The second thing we have to bear in mind and look at is our roots. Now again, roots are the turning points. I've got one turning point at negative 1, 11, I've got one turning point here at 0, 4, and I've got one turning point there at 1, 11. What that means is I'm going to have a root of the function here at negative 1, I'm going to have a root of the function there at the origin, and I'm going to have another root of the function there at 1. Now it comes down to looking at the signs. Now here, above this, it's sloping up the way, which means it's positive. So my gradient here is positive. Sloping down the way here, so my gradient's negative. Up here, my gradient's positive. and sloping down the way here, my gradient's negative. So we could take this to tell us the general behaviour of the curve. Because it's positive, I'm going to be coming down the way from a positive direction. I'm then negative, so I'll go down and back up to the 0. I'm then positive, so my curve's going to go up and then back down, and then I'm negative again. So it's going to look something like this. It comes down the way, goes back up and cuts through the origin, comes back down, cuts through the root there, and fires off to infinity. So it's going to be a cubic that looks something along the lines of that. That there's a graph of my derivative in this case. It's key that we remember these things. When you've got a derivative, first thing you need to do is look at the powers. Take one away from the power, and that'll tell you the general shape of the curve. Second thing you do is look at the turning points. That tells you the roots, so that tells you where it's going to cut the x-axis. Then it's the behaviour of the function. Remember, a positive slope, a positive gradient, your derivative's above the x-axis, i.e. it's positive. Downward slope, negative gradient, so your derivative's going to be a negative value there. Positive slope, again back up, so it's above the x-axis again, and a negative to infinity. Bear those steps in mind, what positive and negative slopes mean in relation to the derivative along with the turning points, and you'll be fine every single time.